Hello, how are you today? So today what we're going to do is day 1 of our Unit 6 Triangle Congruence Notes. This has to do with rigid motion. And what is rigid motion? Rigid motion is any transformation as a translation or rotation of a such set that the distance between the points is preserved. Basically, the shape stays the same. So the only one that, if you think back to Unit 3, where we did translations, and rotations and reflections and dilations, the only one that we cannot use in this rigid motion is dilation, and that's because it actually changes the object. So when we're looking at a rigid motion problem, you have to figure out how did you get triangle A to triangle B. In the following problem, state how you moved this shape from A to B. So write your answer in correct mathematical terms. If needed, use coordinate notation. So in this instance, we just basically picked up triangle A and moved it to triangle B, up and over. So we went down 5 and we went over 6. So we would say we translated triangle DEF by moving 5 units down and 6 units to the right. So all we did is we just picked up that triangle and moved it to a different spot, and then we explained what we did. So here's another one. In this one, triangle A is here on the left and B is on the right. And if you notice, it's reflected. And you find that line of reflection, and it just happens to be the y-axis in this one. So we would say we reflect triangle DEF over the y-axis. And then it matches that second triangle. Now what happens if we gain more steps? So this one has not only moved, but it's also been reflected. So it says show triangle DEF is congruent to the prime with a reflection followed by a translation. So we have to do a reflection first. And in this problem, you can reflect over that y-axis again. So we can say we reflect over the y-axis. Then we have to translate. And we're going to translate, and we're going to move. So our reflection would move our triangle to look like this. And then we have to move it down. So if this is D, then we would move it down 1, 2, 3, 4, 5, 6, 7 units. So we would say we translate 7 units down. The question is, if we were to reverse the order, so if we were to translate 7 units down first and then reflect over the y-axis, would it still map A to B? So let's try that. Here we have 1, 2, 3, 4, 5, 6, 7, and we bring down all our other points. Here's now our first translation, and again, if we reflect over that y-axis, it is going to map it. So all this shows is that there is more than one way to do this problem. Okay, and if you look at part C, it says find one additional way to map triangle DEF to triangle B using translations, reflections, or rotations. So is there another way you could map this not by using, let's say, reflecting over the y-axis? So here's my part C. You can write it under yours. I just want to make sure you can see the picture. The first thing we're going to do is let's reflect over x equals -1. And x equals -1 looks like this. So if we were to reflect over this, now how can we move this triangle down to B? Well, we would move right 2 units, so we would translate 2 units right. How many units down? We would go 1, 2, 3, 4, 5, 6, 7 again. And this will translate this whole triangle to triangle B and conserve the congruency. Another thing we're going to have to do this chapter is identify rigid motion transformations. So this in number 4, if you put the point right there and rotate this one image down counterclockwise 90 degrees, that's a rotation. And again, it matches perfectly the other image. This one, if we moved this one to this one, then we just kind of picked it up and moved it, and that's again a translation. One other thing we're going to have to know is congruent triangles to figure it out by just given a congruency statement. So it says geometric figures are congruent if they have exactly the same size and same shape. So corresponding angles and sides, the definition is they are in the same position in figures with the same equal number of sides. So what this means is that you can't say that a triangle and a square are congruent. So it has to be the same sides, same number of sides. So it also says if two figures are congruent, then all pairs of corresponding parts are congruent. And corresponding, remember, it means it's sitting in the same spot. So when we talked about parallel lines and transversals, a corresponding angle was in the same spot. So here's an example. Here we have example 1. We have 2 triangles. I give you that triangle ABC is congruent to triangle PQR. When we are labeling these, the order matters. Okay, if you notice that we started with A, we went up to B and down to C. When we labeled the second triangle, we started with P. Notice they're in the same spot. We went up to Q and down to R. So those positions of the vertices, they matter when you are labeling these. So if we start and try another one, we have A, C, B. This means we started at A, went to C, and then up to B. So if we label the second one, it's going to be P, because it's in the same position, R, Q. We have to use the same flow, P, R, Q. The next one, though, we're going to start at B, and then we're going to go down to A, and then over to C. So when we label the second one, we're going to start at Q, because that's where it begins, down to P, and then over to R. Now, when I say that things are congruent, triangles are congruent, that means that all of their corresponding parts are congruent, which means all their sides are congruent and all their angles are congruent. So if you look, we have side AB that has 1 dash mark. If you go to the other triangle, PQ has 1 dash mark, so that means that this is congruent. AC has the circle, therefore PR also has the circle, so we're going to say that those are congruent. BC is congruent to QR, because those have the 2 dash marks. And then the angles also correspond. So angle A and angle P, since they're in the same position, they are congruent. Angle B and angle Q. And then angle C and angle R. One more thing, if you notice, angle C and angle R are in the same position in that congruency statement. Angle B and angle Q are in the same position of the congruency statement, and same for A and P. Now this means that because ordered matters, it's telling you which shape or which angle is in the same spot, along with sides. So what we're going to do is we're going to give congruency statement. Triangle ATL is congruent to triangle GBS, and we're going to figure out, without drawing triangles, what is congruent. Okay, so AT is right here, and you go to the next one, and what are in the first two positions? GB. Because they're in the same position in the congruency statement, they are congruent. Angle B is congruent to angle T, because again, they're both in the middle. SG is congruent to LA. So notice how you follow in the same pattern. LT is congruent to SB. Angle A is congruent to angle G. Angle L is congruent to angle S. And then if we're going to label this TLA, we're going to have to label the second triangle BSG. Okay, position matters when giving a congruency statement. One more thing we're going to talk about today is the reflexive property of congruence. This is where we have any segment or angle that is congruent to itself. So if you notice, we have three triangles in this image. Let's go with WH. WH is being shared with triangle 1 and triangle 2. It's the same side. This means it's reflexive. That measure is always going to be the same for both. So we can say WH is congruent to WH. Also, angle T is being shared with angle or triangle 1 and the big triangle, triangle 2. So again, that angle measure is never going to change with the different triangles. It's going to be the same on both. Therefore, it is angle T is congruent to angle T. So reflexive property means that it is congruent with itself. So let's put a little math to this. It says given triangle ABC is congruent to DBC, find the value of x. So one thing that we know is that when we have 90-degree angle on one side, the other side is a 90-degree angle. So we can solve for x pretty quickly. So if we add 16, you have 2x is equal to 106, and then when you divide by 2, x is 54. Oh, I'm sorry, 3. Now we need to find the measure of angle DBC, this angle here. Okay, so we basically need to find out what is this angle measure. Now, if you remember, angle D can be congruent to angle A, right? They're in the same position. So we're looking for the measure of angle D, but do we know the measure of angle A? We sure do. It's 49.3. We know one angle measures 90, one's 49.3. And so if you subtract all of those from 180, the measure of angle DBC is 40.7 degrees. In example 4, sometimes it does help to draw your image. Again, draw two triangles. Always label in the same order. So I'm going to start here, C, U, B. So I'm going to have W, I, N. CU has a measure of, I'm going to change my pen, 10x minus 11. CB is 2x plus 8. WI is 3x plus 17. And IN is 6x plus 13. Now you're given four sides, and you have to figure out what can I set equal to solve for x, because that's what we're asking for, solve for x. Since you labeled them in the same order, CU and WI both have values. So what you can do is you can take those values and set them equal to each other. So then when you go ahead and solve, you would subtract 3x, and then you would have 7x minus 11 equals 17. Add 11, so you have 7x equals 28, and then when you divide by 7, x is 4. Now what I could do, and that's all the time I have, so have a good day.